All right, hello. I'm a team member from the team that worked on the Moody Tunes project. What this project allows or strives to do is to allow a user to input their emotion according to these individual characteristics that we defined right here. So that's going to be happiness, sadness, and the excited level. And what we're going to allow for that to happen is we're going to allow for a user to input their emotion on this varying slider right here. And this is going to strive to be able to compute those emotions into a single emotional value, which we've defined via our models. And what this is going to strive to do is this is going to strive to take that computed emotion value and it's going to make an API GET request to our backend servers, which are going to take that emotion value and do different traversals through our graph nodes to possibly find a song that correlates to the emotion value that we've been striving to get. And once we have this target node found, it's going to do different traversals to find the songs that possibly are related to the single emotion value that we've inputted. And the reason this is important, this is going to allow for the user to create a playlist or to get a playlist in return where they can display the song and we can see this playlist being returned. And what this program allows for a user to do is to say maybe they're not fully happy, they're also a little sad as well, and that's going to allow for the user to get a playlist full of songs that relate to this emotion. And the reason or the way we're able to determine which songs maybe correlate to someone that's happier is that the Spotify API, which we're going to be using to power all of this, to power our song catalog, is the Spotify API returns different information related to the tempo, the danceability, and all these different characteristics of a song, some of which Spotify had to compute themselves. So by having access to all this data and all this information from Spotify's API, we were able to design an additional algorithm that was able to be placed on the back end, which allowed for the back end to process and compute the emotional value of each of the songs in the catalog that we have stored. And that catalog consists of over 170,000 songs and allowed for that emotional value to be computed and stored in our data set, which is ultimately going to be represented via nodes in a graph. So if we wanted to look at how this program worked, we're going to be able to increment the happiness level or possibly change the sadness level, possibly change the excited level. And what the user's going to be able to do is the user's going to be able to visualize how the breadth first search traversal and the depth first search traversal will possibly affect the songs that are returned for the playlist, and more specifically, the time that each different search algorithm took. And to have a quick look around the UI right here, we can see that the music player right here is going to have the album art, as well as the title, the album the song is from, as well as the artist who wrote that song. And we're also going to have next and previous buttons to navigate this playlist right here. And we can see right here, our music catalog was provided by Spotify. So if I wanted to perform this computation in this search, I can do a breadth first search reversal, and we're going to have a loading screen as the web application is querying our backend API as well as the Spotify API to get all this album art. So we can see right here that this breadth first search reversal, it did take 85 milliseconds. And we can look right here at the playlist that I've returned and at all these different songs that it believes could possibly be correlating to the emotions that were inputted via the sliders. So we can see right here, there are going to be 20 songs that are returned. And if we wanted to possibly look through and we could click on that song, we'd be able to scroll up and see that that song clicked is now modified in the music player. And we can also navigate through it via the next and previous buttons as well. And if we wanted to, we could compare this directly to the depth first search traversal. And we can see it's loading. And ultimately, we're going to find that after it's loaded, it did take 56 seconds, which is less than the breadth first search traversal. So overall, we're going to be able to look and we're going to see we had a different playlist computed based on different values that were put in. And the user is going to be able to use this to not only get songs that correlate to how their emotions correlate to the songs in the catalog, but also visualize the different time each different search algorithm takes.